guys, welcome to RxTube and part 2 of my series on statins. In this part, I'll be talking about atherosclerosis and how it can cause some pretty serious conditions like stroke and heart attack. And I'll also be talking about how LDL is is relevant to all of this. I know this video is a little bit long, but I promise you it will all make sense at the end. It's all connected. I promise you that. And if you manage to watch through the whole video, you can have a cookie.
Okay, let's talk about atherosclerosis. Let's go down this rabbit hole together. Atherosclerosis is a disease of the arteries. Disease of the arteries, specifically the large and medium-sized arteries. So, when I'm talking about arteries, some examples would be the carotid arteries, which supply the brain. You've got the femoral arteries, which supply the legs. You've got the aorta. And you also got the pulmonary arteries, which take blood from the heart to the lungs to get oxygenated. So what do I mean by disease? So what happens in atherosclerosis is you get the walls of the artery, the arterial walls, becoming harder, and they harden and they become narrow over time. So this takes a very long time. Over a very long time, arterial walls, they harden and become narrow due to the formation of something called an atheromatous plaque. Oh, I said that right. Atheromatous. Anyway, so to keep things simple, I'm just going to call it a plaque, okay? So I'm going to not mention atheromatous, just say plaque. Let's keep it simple. Right, so to understand all of this gibberish, what I'm going to do is I'm going to draw an artery. I'm going to dazzle you once again with my amazing artistic skills. So you've got this artery, which is like, well, essentially a tube. Okay. There's the arterial wall. We're going to have some blood flowing through it. Just normal blood flowing. Everything's going as it should. Healthy artery. No problems. So what I'm going to do now is take a slice out of this wall so that we can kind of look inside the artery. So let's see if I can accomplish this properly. Okay, there it is. Yep, and just take a little bit out of there. Just get it kind of a little bit semi-neat. Right. Okay, so now what we're doing is we're looking inside the artery, and let's say this is the plaque. Okay, this is the plaque formation. So what is actually happening? In order to see that, we will take a cross section from the artery. We will kind of slice through it, and we're going to look at it from the side. So here's an eyeball. And what we're going to see is like this circular-ish structure. So here's an artery. Here's an actual photo of an artery. This is what a healthy artery looks like. Good job, artery. Looking good. And we're going to take a closer look at the wall of this artery. We're just going to zoom into it. Just draw the circle here. Okay, select green. And yep, that should do it. So here's the wall of the artery, and we're going to zoom in again. So we're going to take another zoom in. Right, I'm going to draw a circle here. Okay, let's see. There it is. Wow, I could make Da Vinci jealous, eh? Okay, so we're looking at this even closer, and what you start to see is this endothelial layer. What's an endothelial layer? It's a layer of cells which coats the inside of the arteries. So this is the layer that's exposed to the blood. And what happens is you could end up getting damage to this endothelial layer. What are some of the stuff that can cause damage? You've got smoking, um, high levels of LDL or bad cholesterol in the blood, hypertension, so people who suffer from high blood pressure, um, they can experience this damage to the endothelial layer. You got obesity is another risk factor. You also got diabetes. There are others involved as well, but these are just some of the more well-known kind of risk factors that can cause this damage to the endothelial layer. So for the purpose of this video series, we are focused on LDL. So what does this damage do? It allows LDL cholesterol that's floating around in the blood to get into the cell wall. And there is an immune response because of this. So the body has an immune response and it sends white blood cells, the immune cells, to deal with the problem. And the white blood cells, they enter through the endothelial layer and they get into the cell walls as well. And what you end up having is this, well, there are other stuff involved as well, but let's focus on just the white blood cells, the immune cells, and the LDL. So because of this population of stuff inside the cell wall and underneath the endothelial layer starts to bulge out and you get the beginning of the formation of the plaque. So you've got the white blood cells in here, the immune cells, and you've got more LDL floating around in the blood. So any more LDL that is just kind of in the blood, let's just zoom in one more time. What that's going to do is it's going to enter through this leaky, damaged endothelial layer and add to the mass of the plaque. And so the plaque will basically continues growing. Meanwhile, these white blood cells, these immune cells, they do what they're programmed to do. They attempt to destroy the LDL in the plaque, because that's what they do with bacteria or foreign bodies that attack the body. They eat them up and they destroy them that way. However, LDL is a bit too much for these guys, and they can't handle it. They keep eating and they gorge on the LDL and they die. They just keep eating until they die. Poor guys, dying in the line of duty. We salute you. And these dead white cells, these dead immune cells, are called foam cells, because if you look at them under the microscope, they look kind of foamy. And because scientists are pretty creative with their naming, because they look foamy, they call them foam cells. Right. So this is basically what is inside this plaque. There is a whole lot of other stuff involved as well. You've got smooth muscle cells, you've got collagen, calcium crystals, but I want to focus on the more important things, primarily LDL, so I'm just going to keep it simple like that. Right, so you have this plaque growing over time. Again, remember, it takes a very long time for this to happen. And over time, it just keeps growing and growing, protruding into the lumen, into the space where the blood is flowing, blocking more and more of it, and restricting more and more blood flow downstream as time goes by. So if you look at a real image of a blocked or narrowed artery and compare it with the healthy one, which I showed earlier, you can really see the difference, in the size of the pipe. Basically, it's quite a bit narrower. Right. So basically, yeah, I mean, it's kind of obvious when you look at it that way. You have a narrower artery. Let me just fill in this plaque over here. And it goes without saying that if you narrow a pipe, make it, just fill this in here. Basically like you're squeezing down on a hose, right? Yeah, if you squeeze it down, you're gonna reduce the water flow further downstream. Now, this is bad because what could be further downstream? You know, that's the important question. You could have some pretty important organs further downstream. For example, you could have the brain. So now, if you're narrowing the arteries supplying nutrients and oxygen to the brain, you could have some pretty serious consequences. People could suffer from dizziness, loss of balance or coordination, confusion, severe headaches, sudden weakness. These are just some examples. There could be other consequences as well. You could also have further downstream, you could have the heart. These are like the main organs, right? So these are organs you really don't want to mess around with. So if you have the heart and if you restrict the blood flow to the heart because of the narrowing of this artery, people can experience chest pain, otherwise known as angina, breathlessness, tiredness, irregular heartbeats. Again, you know, some pretty serious consequences. If you restrict blood to the periphery, so the limbs like the arms and legs, at the extremities, people experience numbness, pain, and in certain situations, even dangerous infections could set in. So some pretty serious consequences can, as a result of this narrowing of the arteries. So one thing that can happen to this plaque while it's sitting there, and I promise this will be the last thing I'll talk about in this video, is the endothelial layer can rupture. The endothelial layer can break up, exposing these foam cells to the blood. So when that happens, you have a fairly rapid response in the form of a blood clot forming. And a blood clot, there you go, there's a blood clot, and happens fairly quickly. This blood clot, otherwise known as a thrombus, narrows the artery further. So if we have another look at the artery sideways, here's the plaque. It is already narrowing the artery quite a bit. On top of that, you have this blood clot forming, and it's forming pretty quickly too. So it's not happening slowly like the plaque formation. So you've got a narrow artery becoming even narrower very quickly. Now, if this happens in an artery that is supplying, let's say, the brain, then you're depriving the brain tissue of important nutrients and oxygen, and you're going to get tissue death, which can lead to a stroke. Same thing can happen in the heart. You're depriving the heart muscles of important nutrients and oxygen, and you're going to get tissue death, which can lead to a heart attack. Another thing that can happen to this blood clot is it can break up and become an embolus. Now, this embolus, it can travel through the bloodstream and until it hits an artery where it's too narrow for it to pass through. When that happens, it blocks that artery, and if it happens to be the brain or the heart, you get the same consequences. So yeah, it's pretty serious stuff, you know, pretty scary stuff because it happens so quickly. So to summarize, in order to prevent stroke and heart attack from happening, we want to prevent the formation of this blood clot. And in order to prevent the formation of this blood clot, as well as reduce the risk of these fun stuff, you want to try and reduce the risk of this plaque formation. And in order to reduce the risk of this plaque formation, we want to reduce the risk factors, which are these ones here. And that's why we're looking at LDL, because it is a pretty important risk factor, the levels of LDL in the blood. It is instrumental in the formation of this plaque, and that's why it's quite important to maintain the levels of LDL at a healthy level in the blood.
And that's it for part 2, guys. Well done for sticking with it till the end.
What year is it?
Now in part 3 of the series, I will bring it all together and talk about the role of the liver in all of this, and eventually, finally, talk about the statins. Hopefully you found this video useful and informative. If you like this video, then well, like, subscribe, but also check out the video, check out my other videos. I'll kind of post them kind of generally here. Hopefully they show up. And that's it, guys. See you in part 3.